First is A3 given whatever is the previous A1, A2. That way P of An given A1 intersection A2 up to An minus 1. That is multiplication rule of n event. Then we have studied total loss of probability. What is that? Total loss of probability is if A1, A2 mutually exclusive and exhaustive. A1, A2 up to An mutually exclusive means if you take any two, intersection is empty. Exclusive and exhaustive means total their union is sample space. That case for any event B, what is probability of B? For any event B, probability of B will be P of A1 into P of B given A1 plus P of A2 into P of B given A2. That way it will go up to P of An into P of B given An. This is called total loss of probability. We have done up to that. Is this okay? If A1, A2, An are mutually exclusive and exhaustive. Mutually exclusive means if we take any two, then their intersection is empty. So they are disjoint event. And B is any event, then if we know each of the event AI probability and P of B given AI, that case probability of B can be obtained by this formula. This is called total loss of probability. Up to that we have studied last class. Total loss of probability P of B A1, A2, AK mutually exclusive and exhaustive. Then for any event B, P of B is P of B given A1 into PA1. That way up to P of B given AK into P of AK. So summation I from 1 to K P of B given AI into P of AI. That is total loss of probability. Is this okay? Hello? Result is okay?
Yes, sir.
सर
हाँ
सर ये स्टेटमेंट मतलब कि देन फॉर एनी अदर इवेंट भी इसका थोड़ा मतलब बता दीजिए.
For any event means whatever event if you choose, then if you know P of B given P of AI and P of B given AI, then you can find P of B by this formula. Okay.
Oh yes.
Any other? So if you know the probability of each of these event A1, A2, AK, and if you know the probability of P of B given AI, then P of B can be obtained by this formula. In fact,
what is probability of B given AI?
that will be given in the question. P of B given AI means conditional probability of B given AI. We will solve one question, then it will be clear. Okay. Before solving question, another thing, again, that is Bayes theorem. What is that? Bayes theorem is same condition A1, A2, AK mutually exclusive and exhaustive set of events. That case, if P of AI and P of B given AI are given, that case what will be P of AI given B? Means I am talking about A1, A2, suppose up to AK mutually exclusive and exhaustive set of events. Mutually, I'm not writing, okay. That case, what is for any event B? P of B is summation P of AI into P of B given AI. I from 1 to K. That is total loss of probability. And Bayes theorem is what is P of AI given B or AJ given B. That will be by the rule it will be P of AJ intersection B by P of B.
Yes, sir.
Now what is P of AJ intersection B? By multiplication rule P of AJ into P of B given AJ. Correct or not? Then P of
Yes.
P of B is the summation P of AI into P of B given AI. I from 1 to K. This is called Bayes theorem. Okay, just application of total laws of probability, nothing else. Anyway, we will solve questions on that. One question is written here. So, an individual has 3 different email accounts. Okay, an individual has 3 different email accounts, and most of our messages, in fact 70% come into account 1. So 70% email come into account 1, whereas 20% into account 2 and remaining 10% into account 3. So individual has 3 email account. Suppose account 1 70% mail come, account 2 20%, account 1, account 2, account 3, account 3 10% mail comes,
Yes.
or we can write this way: 70% comes into account 1. Suppose, say, I will write this way: account 1, 2, 3. Suppose account 1 I am writing red color, 1, 2, 3. So 70% comes in account 1, 20% comes in account 2, remaining 10% comes into account 3. Okay. Of the messages into account 1, only 1% are spam, whereas corresponding percentage for spam messages for account 2 and 3 are 2% and 5%. So in account 1, 1% are spam. Account 2, 2% are spam. Account 3, 5% are spam. What is the probability that a randomly selected message is spam? What is the probability that a randomly selected message is spam? Now see, 3 different email account, 70% comes in account 1, 20% in 2, account 2, 10% account 3. So they are mutually disjoint or not? Of course, if a mail comes into account 1, that cannot come into account 2 and 3.
Yes.
That's why they are mutually exclusive. They are exhaustive or not? 70 plus 20, 90, 90 plus 10, 100%. So that's why if we define AI each message is from account I for 1 to 3, then A1, A2, A3, they are mutually exclusive and exhaustive set of events. Is that okay?
Yes.
Now see, 70% comes into account 1, 20% account 2, 10% account 3. So P of A1 is 0.7, P of A2 is 0.2, P of A3 is 0.1. Up to this okay?
Yes, sir.
Now see, of the messages into account 1, only 1% are spam. Means whatever mails coming into account 1, in account 1, 1% spam mail are spam. So P of B, suppose B is the event, message is spam. So B given A1 means in A1, what is the probability of a message spam? So P of B given A1, that is 1%, so 0.01. In account 1, so we are assuming mails are in account 1. Then what is the spam? That will be P of B given A1. So in account 1, 1% is spam. So P of B given A1 is 0.01. Is that okay? P of B given A1 is 0.01.
Yes, sir.
Account 2 and 3, spam percentage is 2% and 5%. So P of B given A2 is 0.02, P of B given A3 is 0.05. Okay. Now a message is spam. What is the probability? P of B. By total loss of probability, P of B given A1 into PA1 plus B of B given A2 into P of A2, P of B given A3 into P of A3. Then you have to multiply. So 0.001 into 0.7, 0.02 into 0.2 plus 0.05 into 0.1. That way it is calculated. So this is one question related to application of total loss of probability. Is this okay?
Yes, sir.
Now sometimes asks, so then it is Bayes theorem is, so if we know P of B given AI and P of AI, then what will be P of AI given B? That type of things. So it may be asked, what is, if a message is spam, what is the probability that it comes from account 1? If a message is spam, if a message is spam, probability of it comes in, probability of it is from account 1 or it is in account 1. So what will be that? It is spam, then it is account 1. So spam is B, so B is given. Account 1, it is A1. So you have to find P of A1 given B. Is this okay? Hello?
चलो repeat कर दीजिए जरा.
If a message is spam, what is the probability that it is in account 1? We are assuming if a message is spam, what is the probability that it is in account 1? So message is spam, that is given. So B is given. Now probability of it is in account 1. So required probability is P of A1 given B. Now it's okay?
Yes, sir.
So
Yes, sir.
by what is the formula? P of A1 intersection B by P of
By
B.
PP.
P of B already you know. Now P of A1 intersection B will be P of A1 into P of B given A1. All those things are given from that you can write. So definitely some question will be there. Application of Bayes theorem. Again I am telling Bayes theorem. What is Bayes theorem? A1, A2, AK are mutually exclusive and exhaustive set of events. And suppose B is a event, probability of B greater than 0. If we know P of AI, P of B given AI, for all I, that case P of AJ given B can be determined by this formula. AJ given B will be P of AJ intersection B by P of B. So AJ intersection B by chain rule, P of B given AJ into P of AJ. P of B by total loss of this one. So this is our Bayes theorem. Bayes theorem is okay? Hello? Someone mic is on, sound is coming. I don't know.
लास्ट वाला माइक का जो लास्ट में मतलब जो समझा वो समझ में आया.
Which one? This one?
हाँ ये नीचे जो समेशन है वो समेशन कौन सी चीज है?
वो टोटल लॉज ऑफ प्रोबेबिलिटी से जो फॉर्मूला है वही. P of B is what? I from 1 to K, P of B given AI into P of AI. Just we have put that one. Okay.
Okay, sir.
Okay, notes already today I have uploaded it. You go through it.
Sir,
Huh?
the conditional probability of Bayes theorem में कोई difference है?
Conditional probability, हाँ difference है. Conditional probability, that is, see what is the difference? Conditional probability is P of A given B is P of A intersection B divided by P of B, where P of B is not equal to 0. So any event for which P of any event B for which B is P of B is non-zero, we can define conditional probability. But Bayes theorem is if A1, A2, AK are mutually exclusive and exhaustive set of given that type of data is supplied, then only we can apply Bayes theorem. Okay. This is conditional probability. And Bayes theorem is A1, A2, AK mutually exclusive and exhaustive set of events, and B is a event such that PB greater than equal to 0. That case P of AI given B or AJ given B, whatever formula we will obtain, that is Bayes theorem. So here we require a set of mutually exclusive and exhaustive set of events. But here for any event for which PB not equal to 0, we can define conditional probability. Now it's okay?
यस सर। जब ये लास्ट क्वेश्चन जो किया था वो मैसेज वाला, वो बेस्ड ऑन के बेस पे था।
I have done it for Bayes theorem, but it was actually given for total knowledge of probability. Okay. Now I will do one question for Bayes theorem, and when we will solve exercise, there also we will solve some question on Bayes theorem. Okay. Don't worry, we will solve some question in the chapters on Bayes theorem. So here I have 2.31 from the example. I have not written it because it is already in the notes. See. Incidence of a rare disease. Only 1 in 1,000 adults is afflicted with a rare disease, for which a diagnostic test has been developed. So 1 in 1,000 adults is afflicted with a rare disease for which a diagnostic test has been developed. So there is a test for the disease. The test is such that when an individual actually has the disease, positive result will occur 99% of the time. Means actually person has disease, then result will show positive. That probability is 99%. And individual without disease means actually person has not disease but show positive result. Means wrong result giving. That is 2%. Now, if randomly selected individual is tested, the result is positive. What is the probability that individual has the disease? So, we are writing even this way: A1 an individual has disease, A2 individual does not have disease, and B positive test result. A1 individual has disease and A2 individual does not have the disease. See, 1 in 1,000 adult has a rare disease. So individual has disease. What is the probability? 1 by 1,000, that is 0.001. Is that okay? Hello? Is this okay?
यस सर।
A2 individual does not have the disease. So 1.001. So its complement 0.9999. So A1, A2, they are mutually exclusive and exhaustive or not? Individual has the disease, another one is does not have the disease. So both are complement. So they are mutually exclusive and exhaustive set of events. Now B is positive test result. Now see here, test is such that when an individual actually has the disease, positive result will occur 99% of the time. Means actually has the disease and result is test result also positive, that is 99%. So P of B given A1 is 0.99. So A1, A2, so P of B is positive test, so P of B given A1 is 0.99. So negative result 0.99, so it is 0.01. Then when individual 2%. Whereas individual without disease means actually person does not have the disease but positive test result only 2% of the time. So does not have the disease 0.99, 2% positive. So P of B given A2 is 0.02. So P of B given A 1.99, P of B given A 2.02. That way it is written. This is a T diagram. Now what we have to find? These are the information given. What is then if a randomly selected individual is tested and the result is positive? So test result is positive means B is given. What is the probability that individual has the disease? So has the disease A1. So we have to find P of A1 given B. Are you getting the point? What we have to find? Hello? Are you getting the point? What we have to find? Randomly individual is tested and result is positive. That means B is given. What is the probability that individual has the disease? So you have to find A1. So you have to find P of A1 given B. So P of A1 given B we have to find P of A1 given B. So P of A1 intersection B by P of B. That thing is calculated. Is this okay?
Yes, sir.
Okay, you go through the things. Another things we will study, then we will start solving question. That thing is dependent and independent of events. So what is P of A given B? That is, meaning of this is the event B has occurred, then we will find the probability of A. So P of A intersection B by P of B. So A and B are independent. See, actually here P of A given B means the event B is occurred, assuming that we are finding probability of A. That is P of A given B. So obviously depends on B. Probability of A depends on B. So if it does not depend on B, then what will be that? Probability of A given B will be P of A. Here we are finding probability of A assuming the event B has occurred, already occurred. Certainly B has happened. So P of A given B is that finding probability of A assuming the event B has occurred. So when they are independent, that case P of A and B are independent. So if probability of A and probability of A given B will be same, then it is independent. So what is P of A given B? P of A given B is P of A intersection B by PB. That is P of A intersection B equal to PA into PB. That is the condition for independent. Or we can write P of A given B is PA or P of B given A is PB. That way. So independent, either P of A equal to P of A given B, equivalent condition is P of A intersection B is PA into PB, or P of B given A is PA. So A given B means B has occurred, assuming that we will find A. So independent means it does not depend on B. So P of A given B is same as P of A. That is the thing is independent. A and B are two events associated with a random experiment, then A, B are said to be independent if and only if any one condition you can take. P of A intersection B is PA into PB, or P of A given B is PA, or P of B given A is PB. That is independent of two events. Is that okay? Independent of two events? Hello? Definition is okay?
Yes.
Yes, sir.
Tell me, anyone has any difficulty or any suggestion? Tell me, because many of you are not responding. That's why I am asking. So on independent, we will prove many things. So P of A is independent. P of A is same as P of A given B. So it does not depend on B. Or P of B is same as P of B given A. And same thing as P of A intersection B is Pi into Pb. Any one condition we can take as independent of two events. Generally, we will take this one. Okay. So we will give the what is independent of m events. So m events a1, a2, am are independent if we take intersection of all of them at a time, that will be same as product of their individual probabilities. If we take probability of the intersection of all the events, which is same as product of their individual probabilities. That is the first condition. Second condition, for every k events aj1, aj2, ajk, probability of the intersection is equal to product of their probabilities. What is k? K varies from 2, 3 up to m minus 1. See, for m events already it is written, then remaining are m minus 1. For means if we take any number of event, that case probability of their intersection equal to product of their probabilities. That thing is independent of m events. Of course, we have to take distinct means different event. For three events, I am writing A, B, C, and three. A, B, C are independent. What is the condition? First condition is if we take intersection of all the events. What are the all the events intersection? A intersection B intersection C. That will be product of probability of individual this PA, PB, PC. Then three events at a time. Then two events at a time. If we take two events at a time, then P of A intersection B is PA, PB. P of two events at a time. So what are the pairs? AB, BC, CA. So P of B intersection C is PB into PC. P of C intersection A is PC, PA. Then it is independent. So independent of three events clear. What is the condition? And if we take one event, P of A is same as PA, that's why it is 2 to m minus 1. So three events independent is clear. Hello?
Yes, sir.
Okay. And m number of events, what is the definition? If we take intersection of all the events, then probability will be product of their individual. And any k different event. From there, if we take any k different event, k lies between 2 to m minus 1. Then probability of their intersection equal to product of their probabilities. So three events, independent if and only if we take two at a time, P of intersection B, PA into PB, P of B intersection B, PB, PC, P of C intersection is this, three at a time, this one. Okay. One example is given.
सर
हाँ
तो ये जो k वो m minus 1 तक कैसे जा रहा है?
See, or if we take the first condition is up to m. First, if we take k equal to m, 2 to m, then no need to write the first one. Here already k equal to m is included in condition 1. That's why you have written 3 to m minus 1. If you think three events, first condition. So A, B, C. P of A intersection B intersection C is PA, PB, PC. Okay. Then any before 3 it is 2. Any two event A, B, B, C, C A. For that also it is true. That way k varies from 2 to m minus 1. Okay.
नहीं आया सर.
Means
Yes, sir.
all possible intersection. M events are independent. M events, suppose A1, A2, AM are independent. So, what is the condition? If and only if you take intersection of any number of different event from this, probability of any number of intersection of any number of different event equal to product of their individual probabilities. Okay. First you probability, if and only probability of intersection of any number of event. Of course, that number it will be 2 to n. What is the minimum intersection? Intersection of minimum 2.
Yes sir.
So probability of, I am writing that way, intersection of event, just intersection of course we have to take different event, intersection of different event equal to product of their probabilities, product of the probability, product of the individual probabilities. Okay, because how we are generalizing individual probability, see how we are generalizing the thing. Two event A and B independent if P of A intersection B is PA into PB. Using that we are generalizing the thing. Okay. For two event they are independent, P of A intersection B equal to PA into PB. Same thing we will apply. Probability of intersection of the events is equal to product of their individual probabilities. Now, so what are the intersection? So at least we have to take two distinct event, correct or not?
Yes sir.
Two different event. So A1, A2, A1, A3, A1, 4, A1, A4, that way A1, AN. Similarly, A2, A3, A2, A4, that way we will take. So if we take any two different event, product of their intersection, probability of their product of their intersection, sorry, probability, if we take any two different, P of AI intersection AJ into PAI PAJ. Similarly, if we take 3, AI AJ AK will be P of AI into P of AJ into P of AK. That way it will go. So at least two event required for intersection. That's why M varies from 2. 2 to what? Up to M. Correct or not?
Yes sir.
But M case is included in the first condition. First condition is A1, A2 up to AM intersection equal to product of this. That's why K varies from 2 to M minus 1. If you do not write this one, that case you can mention here 2, 3 up to M. Now it's okay?
Yes sir.
For everyone it is okay?
Yes, sir.
Okay. Then, so this is PS3 note. So one question is done. Some event are independent, some are not. That way it is event. So what is the question? Let the equally likely outcomes of an experiment be one of the 4 points in the 3-dimensional space. So sample space is given 4 points. I am writing the things. Sample space S is given 4 points. They are equally likely 1 0 0 0 1 0 0 0 1 and 1 1 1. Wait, here how it is written A B C, that way it is written. Suppose A is the event, x coordinate 1. B is the event, y coordinate 1. C is the event, z coordinate 1. What is A? What is the set A? One zero zero
1 1 1.
1 1 1. So what is the probability P of A?
1 by 2.
2 by 4, that is half. Yeah, I will write in the next page. What is the event B?
0 1 0 1 1 1.
0 1 0 1 1 1. What is C? Sorry, 0 0 1.
3 0 1 1.
So what is probability of A? 2 by 4. P of B? 2 by 4.
2 by 4.
P of C? 2 by 4.
2 by 4.
Now we will verify whether AB, BC, CA or ABC dependent or independent, that we will verify. So what is A intersection B? What is A intersection B?
1 1
X
1.
coordinate 1, Y coordinate 1. So P of A intersection B, that will be P of A intersection B is 1 1 1. That probability is, what is the probability A intersection B? 1 by 4. Correct or not? Hello?
Yes, sir.
1 by 4. So that is PA into PB or not? PA is 2 by 4, PB is 2 by 4. So 4 by 16, 1 by 4, which is same as PA into PB. So that implies A and B are independent. A and B are independent. What about B and C? What is B intersection C? That is also 1 1 1. 1 by 4 equal to PB into PC. This implies B and C are independent. What is C intersection A? That is also 1 1 1. 1 by 4 PC PA. So C and A are independent. What about ABC? P of A intersection B intersection C. So X coordinate 1, Y ABC, X coordinate 1, Y coordinate 1, Z coordinate 1.
Not independent.
1 1 1. So that probability is 1 by 4. Not equal to PA, PB, PC. That means A, B and C are not independent. So if we take any two, then they are independent. But when we are taking three at a time, that is not independent. Is this okay? Dependent, independent? Hello? Dependent, independent is clear?
Yes, sir.
Okay. One thing, some results are there. A and B independent implies A and B dashed are also independent. A and B are independent implies A and B dashed are independent. Can you prove this? See, A and B are independent. What is the condition? A and B are independent. That means P of A intersection B is PA PB. Now we want to show A and B dash are independent. Then what we have to show? P of A intersection B dash is PA into PB dash. That we want to show. So how we will show this? Using this relation we will show it. So P of A intersection B dash. Do you know any formula? P of A intersection B complement? Probability of the A minus probability of their intersection minus P of A intersection B. We have already proved it. Already it is proved. A intersection B complement is P of A minus probability of their intersection. Now P of A by independent, P of A intersection B is PB. We will apply that one. P of A minus PA PB. Then PA is common. 1 minus PB. What is 1 minus PB? PB dash. So PA into P of B dash. So we have started from A intersection B dash. That probability is PA into PB dash. That's why A and B dash are independent. Is this okay? Hello?
Yes, sir.
Anyway, in fact, if A and B are independent, A, B dash, A dash B, A dash B dash, all are independent. I will share a handwritten solution. There you can see. In the exercise, those things are there. Okay, then we will solve questions on these topics. Means dependent, independent, and Bayes theorem, total laws of probability. We will solve questions on that. So these things are in 2.4 and 2.5. Okay, in chapter 2, 2.3 is not here. So we have covered theory portion in chapter 2 except 2.3. 2.3 is not in our syllabus. So conditional probability, independent of events, those things. Bayes theorem, total laws of probability. If you see chapter 2, here 2.4 is conditional probability. Conditional probability, some then it is total laws of probability. After that, Bayes theorem. These are in 2.4. Then 2.5 independent of events. So next class we will solve questions on these two exercises, 2.4 and 2.5. Okay. Many questions are done here. 2.4. Anyway, exercise we will start in the next class. Anyway, we can solve one more questions from here. Mm. Suppose this means here mainly first few questions values are given. From that we have to find some probability. Anyway, I am see for any 56 for any events A and B with P of B greater than 0, so that P of A intersection B plus P of A dash intersection P of A given B plus P of A dash given B will be 1. A and B with probability of B greater than 0. We have to show P of A given B plus P of A dash given B is 1. So how we can prove that? P of A given B plus P of A dash given B. It is given P of B non-zero because it will be in the denominator. So P of A intersection B by P of B. This will be by formula P of A dash intersection B minus P of B. What we can write next step? P of A intersection B by PB. See, P of A dash intersection B. What will be that? P of B
minus P of A intersection B.
minus P of A intersection B divided by P of B. What is this? This is one
Yes, sir.
simple proof. Okay, so many questions I have written. After chapter 2, I will send you whole this handwritten solution 2.1 and 2.4 to 2.5. So you solve here from here question 45, 47, this one also, this is 50, 54, 58, 59, many questions are done here. Okay, on Bayes theorem, then conditional probability, total loss of probability, those things are in 2.4. Then 2.5 questions are there. Many questions are here. So next class mainly we will solve questions on that. Then we will go to the new chapter. Okay, wait, I will take attendance. So class is okay? Any doubt or any query, tell me. Or any suggestion? How many of you are attending? 78. I think all are present. 78 means 76. So I am giving full attendance, okay?
Okay, sir.
Thank you, sir.
Thank you,
But
sir.
but
Thank
someday
Yes, sir.
someday if it is below 70 or 75, in that case I will take attendance.
Okay, sir.
But don't
Okay,
tell
sir.
others. I am taking
Okay,
this
sir.
way, don't tell others.
Okay, sir.
Okay, sir.
Thank you, sir.
Thank you,
So
sir.
way of teaching is okay or not? That is main question.
Yes, sir.
See,
Yes, sir.
Yes, sir.
things will be more clear when
Yes,
you
sir.
are coming in the classroom, because
Yes, sir.
in board that is best. Anyway, okay.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Okay, bye.